Welcome to our physics lesson. My name is Purity Anzelimo, and in our lesson today we want to do a conclusion for the topic waves 1, and therefore we are going to look at KCSE questions from the topic, and that is what we are going to solve during this lesson. So we look at the KCSE questions on waves. Our topic is waves. So having tackled the topic waves 1, we want to see whether we can be able to answer questions from the past papers, that is KCSE. Some few questions. We are going to do like 7 questions from the past papers. So we are going to solve each at a time. So the first question is here. Some are going to be theory, others we are going to calculate. So number 1, so that's the first question. Give one example of a longitudinal wave. It's carrying 1 mark. We think that longitudinal waves are waves whose vibration of particles is parallel to the direction of wave travel, and we gave one example of a longitudinal wave. Which one is that? The sound wave. That's okay. We move on to question number 2. So that's our question number 2. We are told that the audible frequency for a certain person is 30 Hertz and 16,500 Hertz. So we are told to determine the largest wavelength, because here we are going to determine wavelength in 2 ways, in 2 positions, whereby the frequency is 30 and where it is 16,500. So we are told to determine the largest wavelength of sound in air the person can detect. And we have been given the speed of sound in air to be 330 meters per second. So we can first approach it by first calculating the wavelength when the frequency is 30 and the wavelength when the frequency is 16,500, and then we are going to pick the largest, because here we'll have the largest wavelength. Or we can simply come and say we know that the wave equation V is equal to frequency multiplied by the wavelength, and therefore we say if we make frequency the subject of the formula, then it means that we are going to have the speed divided by the wavelength. And therefore we can say that we are told to determine the largest wavelength. So if the wavelength is largest, if here we have the largest wavelength, then it means we are going to have the minimum frequency. So we just come and use the frequency when it is minimum. That is when it will give us the largest wavelength. So we just come and use this frequency, because that is what is going to give us the minimum frequency. Because we are told that the range, the audible frequency for a certain person is 30 Hertz and 16,500 Hertz. So we are told to determine the largest wavelength of sound in air the person can detect. So the largest wavelength will be when the frequency is smallest. So we simply come and apply the wave equation. So we are going to use the smallest frequency here. So our frequency, we are going to use it as 30 Hertz. Then we are told that the speed of sound, V, is 330 meters per second. So we want to get the wavelength. And in our case, we are saying it is the largest wavelength because the frequency is smallest. So in our formula, V is equal to wavelength multiplied by frequency. We can make wavelength the subject of the formula, which will be equal to the speed divided by the frequency. So we are going to have our V as, we have it as 330 meters per second divided by the smallest frequency or the smaller frequency, which is 30 hertz. So when we divide this, we can cancel the 0 and the 0, 33/3, we get 11 meters. So that will be our largest wavelength that the person can detect. Because when you use this other one, 16,500 hertz, then it means that we are going to have the minimum or the smallest wavelength. So our largest wavelength is 11 meters. We move on to question number 3. So that's our next question. We are told that the wavelength of a radio wave is 1 kilometers. 1 kilometer. Then determine its frequency. Take the speed of light as 3.0 times 10 power 8. 3.0 times 10 power 8. Maybe you may be asking why we have been given the speed of light and yet here we are having a radio wave. Now in Form 4, you will learn about the electromagnetic waves. And we learn that all electromagnetic waves travel at the speed of light, which is 3 times 10 power 8 meters per second. And radio wave is an example of an electromagnetic wave. And therefore, it is also going to travel at the speed of light. So in this question, the wavelength is given as 1 kilometer. We are told to determine its frequency, and we have been given the speed of light, which is the same as the speed of the radio wave, as 3.0 times 10 power 8 meters per second. So before we calculate the frequency, we can see the speed is in its SI unit, but the wavelength is not. So we need to convert kilometers into the SI unit of wavelength, which is meters. And we know very well that 1,000 meters make 1 kilometer. So it is an equivalent of 1,000 meters. So our wavelength is 1,000 meters. And therefore now we can apply the wave equation. V is equal to frequency multiplied by wavelength. Our V is 3.0 times 10 power 8 is equal to our frequency, which is in question, multiplied by 1,000 meters. So we can have this as 3.0 times 10 power 8 equal to 1,000 multiplied by the frequency. So we are going to have 3.0 times 10 power 8 equal to 1,000 F. We divide both signs by 1,000 so that we can get our frequency as 3.0 times 10 power 8 divided by 1,000. In this will be the same as we have 1, 2, 3, 4, 5, 6, 7, 8 divided by 1,000. This is what it means. So we divide by 1,000. So we are going to end up having 300,000. That's our frequency hertz. So our answer will be 300,000 hertz. If we want to change it into kilohertz, we can divide it by 1,000 because 1,000 hertz make 1 kilohertz, and therefore we can end up getting 300 kilohertz. So that will be the frequency of the radio wave. So that is it. We can move on to our next question, number 4. So question number 4, we have the following. So here we have a displacement time graph for a progressive wave. This is time in seconds. And here we have our displacement. And the displacement is in centimeters. So then we have our wave. So we want to draw the wave, and from it we can now answer the questions. So that is to guide us so that we can have the same amplitude. So we have it this way. So that is our wave. And we have it this is 2, this is -2. Here we are having 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and finally 55. So our questions are as follows. Number 1. So we have been told that the figure below shows a displacement time graph for a progressive wave. You can see its displacement against time, and this is our wave. So the first question, we are told to state the amplitude of the wave. Now before we state the amplitude of the wave, we have been told that these are displacement time graph for a progressive wave, and we can see the type of this wave is a transverse wave. It has crest and troughs alternating. So it is an example of a transverse wave. So we are told to state the amplitude of the wave. So the first thing we need to ask ourselves, what is amplitude? We say that amplitude is the maximum displacement from the mean position. And our mean position is this point here. So the maximum displacement, and remember we say that the SI unit for amplitude is meters. So from this we can see clearly that the maximum displacement on either sides is 2. So our amplitude is 2 and the units are centimeters. So we convert it into meters to make it in its SI unit. And we know that 100 centimeters make 1 meter. So we are going to have it as 2 all over 100, which is 0.02 meters. So that is the amplitude of the wave. We move on to part 2. We are told to determine the frequency of the wave, and it's 4 marks. Number 2, determine the frequency of the wave, and in this exam it was 4 marks. Now we need first to know, what did we say its frequency? Frequency is the number of oscillations in 1 second. Number of oscillations in 1 second. So if we look at our time here, there is nowhere we have 1 second. But we can see clearly, we can calculate how many oscillations are there in 55 seconds. Then we ask ourselves, what about in 1 second? So we want to calculate the complete or the number of oscillations in 55 seconds. So we start from here. We don't start here, we start where the wave begins. So if you look at this part, this is a quarter of a wave. Because if it were on this other way, then this will be another quarter making a half. So this is a quarter, this is a half, this is a half, this is a half, this is a half, and this is a half. So a half plus a half, that is 1, plus 2 halves, again those are 2, 2 and a half, 2 and 3 quarters. You can see clearly that this is 1, 2, 2 and a half, 2 and 3 quarters. So we can say that 2 and 3 quarters oscillations are covered in 55 seconds. And since we are saying frequency is the number of oscillations in 1 second, so we ask ourselves, what about in 1 second? How many oscillations are those? and that is our frequency. So we are going to have it as this, 2 3/4. 2 3/4 is the same as 2.75 multiplied by 1 divided by 55. So what do we end up getting as our frequency? You can use your calculator. So we have 2.75 divided by 55. So we end up getting our frequency as 0.05 hertz. So that is the frequency of the wave. Number of oscillations in 1 second. Part 3 of the question, which is the last part of this question. So part 3. So that is the other part of the question. We are told that given that the velocity of the wave is 20 meters per second, determine its wavelength. So in this, given that the velocity is 20 meters per second, determine the wavelength of the wave. And we know that we had calculated the frequency already. So our frequency, we had gotten it as 0.05 hertz. So we want to move ahead and calculate the wavelength. And since we have the speed and we have the frequency, we can apply the wave equation. So we come and apply the wave equation. Apply the wave equation to relate frequency and wavelength. So our speed is frequency times wavelength. So is 20, our frequency is 0.05. We want to calculate the wavelength. The two are in their SI units, and therefore the wavelength will also be in its SI unit, which is meters. So we have 20 equal to 0.05 by wavelength. So to make wavelength the subject, we divide both signs by 0.05 by 0.0. So we'll end up getting our wavelength to be 20 divided by 0.05, which is the same as 2000 over 5, which is the same as 400, and these are meters. So our wavelength therefore is 400 meters. So that's how we calculate wavelength from the wave equation. V is equal to frequency multiplied by the wavelength. Hopes that question is clear. So it was one question carrying, those are 4 marks plus 3, 7 plus 1, 8 marks on waves 1. So we move ahead and look at question number 5. We are in question number 5. I said we are going to look at 7 questions. So number 5. So that's our next question. We are told to state 2 differences between electromagnetic waves and mechanical waves. So to answer this, we can draw a table. On one side, we have the electromagnetic waves, and on the other side, we have the mechanical waves. If you remember keenly, we divided waves in 2 broad categories. That is the electromagnetic waves and the mechanical waves. So the first difference is going to be the definition. So we can start by the definition. So we have the electromagnetic waves and we have the mechanical waves. What did we say are electromagnetic waves? They are waves which do not require a material medium for their transmission. So we are going to say they do not So whereas the mechanical waves are waves that require a material medium for their transmission. So we can say that they require, so that's one of the differences between the two. For EM waves, they do not require material medium for their transmission, while mechanical waves require material medium for their transmission. Something else that you need to note on electromagnetic waves, all electromagnetic waves travel at the speed of light. So they travel at the speed of light. But for the mechanical waves, it depends with the medium. Is the medium water? Is the medium maybe a spring? So it will depend with the medium. So we can say that they travel at varying speeds. So make note of that. For all electromagnetic waves, they travel at the speed of light, which is 3 times 10 power 8 meters per second, whereas for the mechanical waves, they will travel at varying speeds depending with the medium. And therefore, from this, we can say that for the electromagnetic waves, they travel at a higher speed, a very high speed of 3 times 10 power 8 meters per second, whereas for the mechanical waves, they travel at a lower speed. So if we compare the two, we can say that electromagnetic waves travel at a higher speed than the mechanical waves. Then we also say that with the electromagnetic waves, all of them are transverse in nature. So we can say for electromagnetic waves are transverse. They are transverse in nature. What about the mechanical waves? Mechanical waves can either be transverse or longitudinal. So we have been told to state two differences, but we have been able to give 4. So when you are asked such a question, you can give any 2 among the 4 that we have given. So we have seen electromagnetic waves, mechanical waves. Electromagnetic waves do not require material medium for their transmission. Mechanical waves require material medium for their transmission. Electromagnetic waves travel at the speed of light, while mechanical waves travel at varying speeds. Electromagnetic waves travel at a very high speed, whereas mechanical waves travel at a lower speed. All electromagnetic waves are transverse in nature, whereas the mechanical waves can either be transverse or longitudinal. So that's our question number 5. We can move ahead and look at question number 6. So we can move on to the next question, number 6. So the figure below shows the displacement time graph for a certain wave. So we want to have the wave here. This is displacement. We have time in seconds. This, as I said, is to guide us. So that's the wave. Then we have been given the following for the wave. We have been told that this point is 7.0 times 10 power negative 3 seconds. Then we've been told at this point is 3.5 times 10 power negative 3. So that is what we have, and we are told determine the frequency of the wave. So here is the question. So we've been told the figure below shows the displacement time graph for a certain wave. As we can see, we are told to determine the frequency of the wave. And we have been given time at this point and also at the other point. And we know that frequency refers to the oscillations in 1 second, or number of oscillations in 1 second. So as we can see here, how many oscillations do we have? We can calculate and see the number of complete oscillations for this wave. So we have this. This is 1, 2, 3. So we have 3 waves. That is 3 complete oscillations. 3 complete oscillations, and they are being covered in 7.0 times 10 power negative 3 seconds. So we have 3 oscillations in 7.0 times 10 power negative 3 seconds. And now that we know frequency is the number of oscillations in 1 second, we ask ourselves, what about in 1 second? How many complete oscillations, or how many oscillations are we going to have? And that will be our frequency. So we are going to have 3 times 1 divided by 7.0 times 10 power negative 3. So we can calculate this using your calculator. So we are going to have 3 divided by 7 times 10 power negative 3. So what do you end up getting? So we can write it to 2 decimal places. So we are going to have 428.57. And this is frequency. So it is 428.57 hertz. So that is what we are going to have for that, 428.57 hertz. So because the number of complete oscillations here are 3 in 7.0 times 10 power negative 3 seconds. So in 1 second, we want to know the oscillations. There will be 428.57 hertz. So that will be our frequency. So finally, we can look at question number 7. Question number 7. We've been given the following. So we have the following. We are told that a broadcasting station produces radio waves of wavelength 800 meters. Determine their frequency. And we have been given that the speed of light is 3.0 times 10 power 8 meters per second. It is the same speed that we are going to use for radio waves, because radio waves are electromagnetic waves, and therefore they travel at the speed of light. So we are going to have analyzing the question. We want to analyze the question. The wavelength of the radio waves is 800 meters. We are told to determine their frequency, and we have been given the speed to be 3.0 times 10 power 8 meters per second. So when we have that, we can check. The two are in their SI units. So we just come and apply the wave equation, or the equation relating speed, frequency, and wavelength. Speed is equal to frequency times wavelength. Our V is 3.0 times 10 power 8 is equal to frequency multiplied by 800, which is our wavelength. So we have 3.0 times 10 power 8 equal to 800 F. So to get F, we divide both sides by 800, the two sides by 800. So we end up getting our F as, we can divide that. We are dividing by 800. What do you end up getting? So that is 3 times 10 power 8 divided by 800. And you end up getting the frequency as 375,000. And therefore we can say our frequency is 375,000 hertz. We can convert it into kilohertz, whereby 1,000 hertz make 1 kilohertz, and therefore we can say it is equal to 375,000 all over 1,000, which is 375 kilohertz. So that is the frequency of those radio waves. So that is it. Those are some of the questions that have ever been tested in the KCSE, like this one was tested in 2020, just the other day. So you can see they are not very hard questions. They are questions that you can be able to solve having gone through the topic waves 1. So I'd like to leave you with some questions again from the KCSE past papers. Try to work them out and see whether you've understood the topic. So an assignment here for you. Can give you a few questions. Number 1. So that is the arrow. This is the particle here, P. So here we have Roman 1 and Roman 2. And the question is as follows. And the question is carrying 1 mark. So you have the following. The figure below shows an arrow which indicates the direction of travel of a wave in a medium. P is a particle of the medium that is in path of the wave. So here we have the arrow indicating the direction of travel of a wave. This is the particle. So you are told in the space that you have been given, that is after you write the question, the space that you leave here, sketch a diagram to show how the particle P moves when the wave is a transverse wave. So you sketch here for the transverse and Roman 2 for the longitudinal wave. And this you can get clearly from where we were defining the transverse and the longitudinal waves. That's question 1. Then number 2. Number 2, you can work out the following. Sorry, it is not a displacement time, but a displacement distance graph. So I'll draw the wave here. These are the questions that follow. So I want to draw the wave. We have been told the figure below shows a displacement distance graph for a certain wave motion. So indicate on the figure with letters A and B any 2 points that are in phase. We learned about phase and phase difference. Then Roman 2, determine the amplitude of the wave, wavelength of the wave. And Roman 3, you are given that the frequency of the wave is 50 hertz. Determine the 1 period, and number 2, the speed of the wave. So we are going to have the wave here so that you can determine all those that are in question from it. So it is a displacement distance graph. It's in meters. Distance is also in meters. So this is what we have for our wave. So that is the wave, and we've been given the following. This is 10, 20, 30, 40, 50, and 60. So that is the wave, the displacement distance graph for that wave motion. So you can use it to answer the questions that you have been given. So that is on waves 1. Basically, waves 1 is on, we talked about the major classification of waves, the EM waves and the mechanical waves. Then we went ahead to transverse and the longitudinal waves. We looked at phase and phase difference. We also went ahead and looked at terms associated with waves, the terms that we are using here, the amplitude, the period, the frequency, the wavelength. Then finally we looked at the wave equation, whereby we looked at the relationship that exists between the frequency, the wavelength, and the speed, and we have used it in solution for various questions. And now we have also been able to look at as an example or examples of questions that have ever been tested in the KCSE. So you can go through the topic again and be able to answer the questions that can be given from the topic. They can be both theory and also the calculation part. So there is the calculation part and also the theory part. Thank you for following. Keep revising the topic.